Welcome to the session on circular convolution. In our today's session, we are going to learn how to perform circular convolution using concentric circle method and matrix multiplication method. Circular convolution of two sequences x1 of n and x2 of n is given mathematically by y of n is equal to x1 of n circular convolution x2 of n. It is also represented by y of n is equal to summation m tends from 0 to n minus 1 x1 of m into x2 of n minus m mod n. Steps involved in concentric circle method are as follows. As the name indicates, we have two circles, one along the outer circle, the other one is the inner concentric circle. We need to place the value of the first input sequence x1 of n in the outer circle along the counterclockwise direction. Similarly, place the value of the second sequence x2 of n in the inner circle in the clockwise direction. Multiply the corresponding samples of x1 of n and x2 of n and sum it up. Rotate the inner concentric circle along the clockwise direction to find the subsequent elements of the output sequence. We will solve a problem and understand it much better. Find the circular convolution of two finite duration sequence. x1 of n is given by 1, 2, minus 1, 2, 3 and 1. x2 of n is equal to 3, 2 and 1. If we look at these two sequences, the length of the first sequence is 6, wherein the length of the second sequence is only 3. In order to solve a problem using concentric circle method, the length of both the sequences should be the same. In order to make the length of the second sequence same as that of the first input sequence, we are appending 3 zeros at the end of the second sequence as shown here. 3, 2, 1. We are appending 3 zeros so that the length of this sequence is same as that of the first input sequence. How to solve? So we are going to find out the value of the first element of the output sequence x3 of 0. So draw the outer concentric circle. As we have 6 samples, place all the 6 samples equally well in the outer circle. Mention the values of x1 of n in the outer circle along the counterclockwise direction. Start at this point. Start the first element value at this point. So x1 of 0 is equal to 1. Followed by the subsequent values of x1 of n in the counterclockwise direction. So we have 6 elements altogether. Represent all the 6 elements along the outer circle in the counterclockwise direction. Sketch the inner concentric circle. Equally space all the 6 points along the inner concentric circle. Mark the first origin point of x2 of n, which is nothing but x2 of 0, at the same place where we started with x1 of 0. And represent the subsequent value of x2 of n along the clockwise direction as shown here. Subsequent values are to be represented along the clockwise direction. After representing these values, we are supposed to find out the first element of the output sequence, which is x3 of 0. And it is given by multiplying the subsequent element of the outer circle and the inner concentric circle. So in this case, it is 1 into 3 plus 2 into 0 plus minus 1 into 0 plus minus 2 into 0 plus 3 into 1 plus 2 into 1, and we have arrived with the value of 8. So 8 is the value of the first element of the output sequence x3 of n. Similarly, we are supposed to find out the value of x3 of 1. So for finding out the value of x3 of 1, the outer circle values remain untouched. We have to move the value of x2 of n, or the second sequence, by pushing the first element, origin element, to the next unit. So we will see how it works. The value of the outer circle remains untouched and it is retained. So it is retained and it is remained untouched. In the inner circle, place equally all the 6 samples of x2 of n. So earlier, the origin point was here. We need to push it by 1 unit along this side and place the subsequent value of x2 of n along the clockwise direction. So as it is shown here, and find out the value of x2, x3 of 1. So by just multiplying subsequent value of the outer circle and the inner concentric circle. So in this case, it is 1 into 2 plus 2 into 3 plus minus 1 into 0 plus minus 2 into 0 plus 3 into 0 plus 1 into 1. And the answer is 9. We will move on to find out the value of the next element of the output sequence. So retain the outer circle as such without disturbing it. In the inner concentric circle, we have to push the origin value 1 unit ahead. So now the origin point of x2 of n starts here. Earlier it was here. We are pushing it by 1 unit ahead and then represent the subsequent value of x2 of n in the clockwise direction. So now moving on to find out the value of the element x3 of 2. So how are we going to do it? We have to just multiply the subsequent values of the outer circle and the inner concentric circle. So in this case, it is 1 into 1 plus 2 into 2 plus minus 1 into 3 plus minus 2 into 0 plus 3 into 0 plus 1 into 0. And the answer is 2. Moving on to finding out the value of the next output sequence, which is x3 of 3. So retain the output circle value of the outer circle as such. In the inner concentric circle, move the origin point to 1 unit ahead. In the previous case, it was here and it is pushed ahead as 1 point and place the value, subsequent value of x2 of n along the clockwise direction. So we will arrive at the value of x3 of 3. So multiply the subsequent value of the outer circle and the inner concentric circle. In this case, it is 1 into 0 plus 2 into 1 plus minus 1 into 2 plus minus 2 into 3 plus 3 into 0 plus 1 into 1. And the answer is 6. Minus 6. So moving on to find out the value of the next element, which is x3. Of 4. So retain the outer circle as it is. In the inner concentric circle, we need to just push the origin point 1 unit ahead. So earlier case it was here, now it is pushed here. After which the subsequent values of x2 of n are placed along the clockwise direction. And in order to find out the value of the output sequence x3 of 4, the subsequent value of the outer circle and the inner concentric circles are multiplied. So it is 1 into 0 plus 2 into 0 plus minus 1 into 1 plus minus 2 into 2 plus 3 into 3 plus 1 into 0. And our answer is 4. So we'll move on to find out the last element. of the output sequence. So the outer circle is remain untouched. In the inner concentric circle, the origin point is moved 1 unit ahead and place the subsequent values of x2 of n in the clockwise direction. Multiply the subsequent values along the outer circle and the inner concentric circle. So in this case, it is 1 into 0 plus 2 into 0 plus minus 1 into 0 plus minus 2 into 1 plus 3 into 2 plus minus 1 into 3, and the answer is 7. So we have arrived with all the 6 elements of the output sequence. We have to pick up all those 6 values and write it in the sequence like this. And hence, the value of the output sequence is x3 of n is equal to 8, 9, 2, minus 6, 4, and 7. So this is how we need to solve a problem using concentric circle method. Hope this is clear. So moving on to how to solve a problem using matrix multiplication method. So in matrix multiplication method, the values of the sequences x1 of n and x2 of n is represented in matrix form. So in the bigger matrix, we need to represent the value of x2 of n. The smaller matrix, we need to represent the value of x1 of n. And here we will arrive with the value of x3 of n, which is nothing but our output sequence. So start representing the value of x2 of n along vertically. So x2 of 0, x2 of 1, x2 of 2, followed by x2 of 3, 4, and 5. So altogether we have 6 elements. The last element of the first column will move to the first element of the next column, followed by subsequent element of the previous column. So x1, x2 of 5 will move up, followed by the successive elements of the previous column. So it is x2 of 0, x2 of 1, x2 of 2, x2 of 3, and x2 of 4. Now this last element, x2 of 4, will occupy the first position here, followed by the subsequent element of the previous column. So it is x2 of 4, followed by x2 of 5, x2 of 0, x2 of 1, x2 of 2, and x2 of 3. Similarly, fill up this matrix. So we have started with x2 of 0 and we need to end up with x2 of 0. In the next matrix, we need to represent the values of x1 of n. So x1 of 0, x1 of 2, x1 of 1, x1 of 2, x1 of 3, x1 of 4, and x1 of 5. So altogether we have 6 elements in x1 of n. And when we apply matrix multiplication to these two sequences, we will arrive at the output sequence, which is x3 of n. So the elements are x3 of 0, x3 of 1, 2, 3, 4, and 5. So we will apply the same problem using matrix multiplication method and check our answers. So represent the values of x2 of n and x1 of n as mentioned previously. So the matrix becomes like this. And how are we going to arrive at the final value? So how to find out the value of x3 of 0, x3 of 1, 2, 3, 4, and 5. So in order to find out the value of x3 of 0, you have to multiply the values of first row with the first column. So it is 3 into 1 plus 0 into 2 plus 0 into minus 1 plus 0 into minus 2 plus 1 into 3 plus 2 into 1. So you will arrive at the value of 8. Similarly, in order to find out the value of x3 of 1, multiply the elements of the second row with this column. So it is 2 into 1 plus 3 into 2 plus 0 into minus 1 plus 0 into minus 2 plus 0 into 3 plus 1 into 1. Similarly, multiply the value of the next row with the column. So you will arrive at the value of x3 of 2. In a similar manner, we will arrive at the value of x3 of 4 and x3 of 5. So finally, the answer that is obtained using matrix multiplication method is given by x3 of n is equal to 8, 9, 2, minus 6, 4 and 7. So it is observed that the value what we arrive with concentric circle method and matrix multiplication method for this given problem is the same. Thank you.